my bell work. It says to write the word equation and then the formula equation. So, word equation. We're taking all the fluff out. So what's my first word? Iron. Iron. What do I need next?
Copper phosphate, yeah. Or copper one.
And what's an and? As a plus. And now we need copper. The Roman numeral, yeah. Phosphate. All right, to produce or decompose it, so you're going to have a verb afterwards, and the verb is represented by an arrow. What's the next word? Copper. Ooh, Cooper, that's my son. Copper. Cooper the Trooper, and we used to call him Cooper the Super Pooper. What was that? After an element. Iron to phosphate. That's what I do. I'm going to start like, I'm going to become like the cat lady, and I'm going to start collecting cats, and I'm going to start with hydrogen, and then I'm going to go with helium, and will that be just so cute? And then you could set them up and take a picture of them, and they're like in the order of the periodic table.
Oh my god.
No?
But how do you know which one is which?
And then it would have, like if I had all all my Persian cats could be lithium and sodium and potassium, and then all of my Bengal cats could be beryllium and magnesium.
No.
All my rag dolls could be. I'm recording this too. Oh my god, I'm sorry.
This is why you don't use our class for your recordings.
What? I know. All right, so formula equation. Iron. What's the formula for iron?
Fe.
Fe. Copper 1 phosphate. 3. Good. PO4. Copper is what? Cu. Iron 2 phosphate.
Let's go.
Fe. Fe what? 3. Phosphate is PO4. And how many of those do we need? 2. All right. Again, these are not observing the law of conservation of mass. The next thing I need you to do is, it says what actually happens to the atoms of the elements during a chemical reaction if the same ones are always present in both reactants and products. Carbon, carbon, hydrogen, hydrogen, oxygen, oxygen, oxygen. So what happens to those atoms? They split up. How can we use scientific words? They're what? They're rearranged, okay? They become rearranged. Now, I am going to do something. I'm going to draw these at the particle level and show you what everything looks like, okay? So I'm going to use red for carbon, and then I'm going to use green for oxygen, and I'm going to use for blue for hydrogen. Okay, so this is what I'm going to be using. This is my key, and you will be required to know how to draw this out as particles, or to be able to recognize them as particles and see what's going on. All right, so let me do CH4. So we have carbon. We have 1 carbon, and it has how many hydrogens attached to it? 4. So we do hydrogen, 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 hydrogen. And to that we are going to add, so we have the methane and we're going to add oxygen to it. So oxygen is O2, so it looks like that. Okay? And then it produces carbon dioxide, so carbon's in the middle. And we have what on either side of it? So we have an oxygen on either side of it. And then we have water. Here's my oxygen, and then we have our hydrogens. Okay? Is everybody good? It always looks like Mickey Mouse, yeah. Everybody good with what I just drew? Okay, so now if I look at that, does it follow the law of conservation of mass? Yes. I hear no. No's are right.
Let's go.
So how I can add atoms? I can either add more of these, I can add more of these, I can add more of these, or I can add more of these. But it has to be these things I can add more of. So what am I going to add to get this to follow the law of conservation of mass? More blues. More blues where? So that means I need to add more water, right? I can't take anything away. So that means I need more oxygen. Oxygen where? On the reactants. And I can't just add one oxygen. They have to occur in two. So now is it observing the law of conservation of mass? Yes. So the thing is you can't mess with these atoms, okay? If I just put one atom there, one oxygen, then I've changed what I have. So it has to be what is in that original equation, and you have to add those different atoms in there. So if I were to go and put this into my equation that we had at the top, how many CH4s do we have? 1, so 1. How many O2s do we have? 2. How many CO2s do we have? And how many H2Os do we have? 2. You're going to do that tomorrow on your homework. I'm going to lecture more about that tomorrow. But I just want to get you guys comfortable in drawing these because you'll either see them in a multiple choice where you'll be given 4 different images and you have to pick which one's not the right one or is the right one. Or you might have to actually draw it with a free response, balance it, and do all that other stuff. Okay, is there any questions over that? So what is classwork today? Classwork today is 8 through 13. And if you have finished that, then you can start balancing if you feel comfortable with it, or working on something, or you can work with me with your test corrections.